Hello everyone, my name is Rachel Bicknell. Today I'm going to tell you how to monitor TL1 devices on the cheap. In this presentation, I will tell you my motivation for monitoring TL1 devices cheaply. I'm also going to explain what TL1 is and the tools to capture TL1 alarms and translate them into SNMP traps. Why TL1? I was working at a small CLEC/ISP in Memphis where they outsourced the monitoring of all the transmission devices to the vendor. The vendor was using its own proprietary TL1 monitoring software to report alarms and outages. When we decided that we wanted to insource the alarm reporting to save a significant amount of money, we looked at various options. Most of the equipment in our network was only running TL1, not IP, thus it could not be monitored via SNMP. To run IP on the equipment, we would have had to shell out a significant amount of money for the virtual IP product. I was indignant that the vendor would make us pay extra money for this when most major vendors include IP software and the SNMP MIBs for free. That's when I thought, why not write a TL1 to SNMP translation agent to capture the TL1 alarms and translate them into SNMP traps? As I started looking for more information about TL1, I found everything I needed to know at www.tl1.com. I immediately found out that TL1 stands for Transaction Language 1 and that TL1 is an ASCII-based language. TL1 became the dominant standard for TDM and optical transmission devices because Bellcore made it a standard via its Telcordia GR833 specification. Before TL1, each network vendor implemented its own, that vendor's own type of ASCII-based control language. Each vendor had a different language, therefore each had to be separately memorized by operators and programmers of operational support systems. Bellcore, in its role as a standard setter for the R-Box, decided in 1984 to specify a standard called TL1. Note that because TL1 is created in 1984, it predates TCP/IP. Serial interfaces were the norm to interact with transmission devices. TL1 also predates SNMP, which started coming together in 1987. In 1985, the first large-scale systems for Bellcore were being delivered. Bellcore required that the network elements support TL1 interfaces, therefore vendors rapidly implemented it. Today, Sonnet and optical vendors also use the TL1 standard. Some TL1-based devices used today are the Cisco ONS 1500 series and the Nortel Optera series. In this example of a TL1 command, number 1 shows the command that is going to be executed, set attribute equipment. Number 2 is called the staging block, which is the equipment name, the port identifier, and the sequence number. The sequence number is like the basic programming language numbering scheme of 10, 20, 30. Number 3 contains the parameters of the command. In this example, it's showing a major alarm severity because of loss of frame. This is an example of TL1 output. It's retrieving all the alarms on the device node B. In this case, the command output is 3 alarms. As you can see from my previous 2 slides, TL1 is not a user-friendly language. In 1984, in the age of COBOL and Fortran, TL1 must have seemed as user-friendly as they come. Another shortcoming of TL1 is that while the original specification works very well, every vendor tinkers with the TL1 specification to have its own additional commands. A third shortcoming of TL1 is that many network monitoring tools do not have TL1 device agents. Most vendors now use IP on their transmission gear, but anecdotal stories have told me that there's a lot of transmission gear out there that's running TL1 only. As I was learning more about TL1, I needed to know the specific commands to get into a TL1 device, grab the alarms in a consistent interval, and then log out at some point if need be. Thus, the three main commands I needed were activate user, which activates the user via login and password, retrieve alarm all, which allows one to retrieve all the alarms on a node or device, and cancel user, which cancels the user's access to the device. Two other useful TL1 commands are retrieve equipment, which retrieves a list of equipment on the device, and if you want more information like serial numbers about the device, retrieve inventory is the command you use. Cisco has also added a few commands that aren't in the Telcordia specification. The ones I found to be most useful in monitoring are, and this slide is a little mixed up, so is retrieve alarm bits, which is the alarms for building integrated timing supply. The next one is retrieve alarms environment, which retrieves the environmental alarms, and retrieve alarm sync, which is another bits alarm. You can find out more about these commands at the cisco.com URL in this slide. Going back to my original problem of how to save the company money, I had the following options. Buy an expensive monitoring package from the vendor, buy our own monitoring package with a TL1 agent as an addition, or we could use open source tools to monitor the TL1 devices we had in the network. We chose number 3 because it was the least expensive. When I initially started my search for TL1 agents to use with SNMP monitoring systems, I found out that Indiana University was using the commercial product MonFox to get their TL1 alarms translated into SNMP for their Nagio system. Advent also has a TL1 agent, which is also a commercial package. We found it very useful to use TL1 emulators during software development. We used the iReasoning Network's TL1 API, but we also found 2 other simulators when researching. As I was searching for other TL1 monitoring tools, I found 2 free tool sets, the Sarah TL1 toolkit and Steve Hessing's CPAN TL1 module. The Sarah toolkit allows the retrieval of TL1 device information without having to know the exact details of how the TL1 command works. This toolkit currently works on Nortel and Cisco devices, but can also be used to execute TL1 commands on any TL1 device. If you want to try doing all this stuff yourself, the Sarah toolkit is probably the best one, in my opinion. Steve Hessing also wrote a Perl extension that is available on CPAN. This program provides a framework to develop specific commands for TL1 devices. It should be possible to write a fully functional TL1 to SNMP translation agent. This would enable one to use SNMP network monitoring tools. Andre Tonk, I hope I'm saying his name right, sorry Andre, wrote a proof of concept Perl script to translate TL1 alarms into SNMP traps. Andre's Perl script goes into the TL1 device, retrieves the alarms, and generates an SNMP trap with the OID syscontact.0, putting the TL alarms into a text format. Does anyone have any questions? Well, thank you for watching my presentation. Yes? Yes, sir?
This is going to be available electronically, right?
Say that again?
Electronic copy? It's going to be made available later?
I believe NANOG will put up
Okay.
the PDF electronically.
Thank you.
Correct?
Yes.
Okay. Any other questions? Well, thank you again. Have a good morning.